Okay, more drawing. Let's see what I'm going to do today. We should probably do the motor for the weapon. Blah blah blah. On this Fury, I made the weapon chain drive, so I guess I'll do the same on my new robot. The first thing I need is a sprocket on the weapon. Might as well make it the same gear reduction. And the sprocket I want to use is a plate sprocket, which was bored out to the same bore as the pipe and then just welded onto the pipe. So we'll just use this one and save a copy of it into the Aggressor folder. And there we go, saved. Change its colour. And constrain it onto the pipe. It's hard to see in this spot. There we go. I won't constrain the ends yet because I like to know how the motor's going to sit first. So we'll just leave it as is for the moment. So we can slide that up and down. Now we need a chain, which is in here. Now I probably should mention that Inventor does have a chain and sprocket generator in the program, the same as the gears, but I don't like to use it. And the reason I don't like to use it is because it doesn't work terribly well with my skeletons. And the main reason is because with the skeleton I like to know the center of the axles, or the center of the axle to the center of the motor, so that I can position the motor correctly. But because the centers of the chains is not easily calculated, then I don't know it before I put the chain in, if I use the chain generator. So what I like to do is have a separate model for the chain that's constructed beforehand, which then has the center points already done as a parameter, and then I can put that into the skeleton and draw where my motor is perfectly before I do any framework. It's just my way of doing it. It's not the way to do it. You can use the chain generators in Inventor and then use the center of the axle to project a hole through. But there's 10 ways of doing one thing. This isn't the right way, and that isn't the right way. They're all right, they're all wrong. So it doesn't matter. This is how I do it. Anyway, this is my chain model. I should point out that I'm not going to take credit for it. I didn't draw this. I downloaded this off the internet. So it looks nice and fancy, but I'm not going to take credit for it because I didn't do it. And what this model actually has, and why I like it so much, is it has a spreadsheet embedded into it. So if we edit this embedded spreadsheet at the top, Inventor will open Excel, because this Excel spreadsheet is the spreadsheet that the guy created when he drew this model, and it has all the parameters in it. It does all the calculations and he tells you how he did it. It's quite nice, I like it. And you can change what series of chain you want, 25, 35. Yeah, it's an American thing, so you don't get much choice. But American chains are pretty standard. And you can change the number of teeth in the front and rear sprockets. And apparently you can select your desired distance between. and then it'll calculate the actual distance. But I don't use that because it never really worked the way I wanted it to, so I've overridden his spreadsheet. So instead of desired distance, I just manually update the number of links, which he did. He calculated, used the spreadsheet to calculate the number of links, and it wasn't working when I put in some desired distances, and it was chucking wobbly. So I just overrid this number, and I tell it how many links I want in my chain. It takes a bit of guessing checking. But at the moment, I've got a 25 tooth big sprocket, 12 tooth little sprocket, and a number 35 series chain, which is go-kart chain or mini bike chain, so you can buy it easily on eBay. Sprockets are a bit harder to buy on eBay. No one seems to sell just normal sprockets on eBay, so you have to buy them special. And how far do I want between my motor? I don't need it as long as 8 inches. Probably only need 4 inches. So let's try 40 teeth. 40. Oh, there we go. That's right, 40. And it says that the actual distance is 3.95 inches. So we'll get 40 links. So we save this spreadsheet, close it. We hit the update button on the chain, and it thinks, and there's our new chain. Looks good, doesn't it? Now, if I go to the parameters section to show you, and scroll down, there's an embedding series, which has embedded section, which is all the parameters that were in that spreadsheet. And if I scroll down, it's use some stupid names, so it's kind of hard to understand. Like, I don't know what a PRN is, or PANGN is, or no links N. I don't know, it's all kind of strange. He does have one in here. There we go. C to C is the center to center distance, which is the center of this sprocket to the center of that sprocket. So I'm going to save this. And for the moment, I'll just copy him into my assembly so I don't lose it. And then we'll close it. So there's my chain. Go into the skeleton, parameters, link. We link to the chain model, and we go through this huge list of parameters to find C to C, center to center. And we'll bring that one in. And there it is, 3.955 inches. Done. So now I need a new sketch for my motor mount. So if I draw center of my, so that hole there will be for the motor, and the center point of that motor to the center point of the weapon would be C to C, which is A, which isn't really what I wanted. It's probably a bit long looking at that, because it comes straight to where this plate is. We could probably have the motor sitting outside of the armor and hope no one ever hits it. Or we could have it inside the robot. Oh, so many choices. Do we put it inside the robot? Or do we put it outside? Common sense says to put it inside. So maybe that chain needs to be longer. Ah, we'll figure it out later. We'll just finish off this piece first. Too much thinking does not make me work up. And we'll make this 15. And we will draw in the motor mount holes. So that's where the motor mount would sit. So now I need to make this plate go right down and make it into a proper motor mount for the moment. So probably should make it the same as the back and just project up and around. So we'll project through the back. There we go, that's the back. And project up to there, start up to there. And we'll put an arc on his nose. Nothing more tangential. Yeah, whatever. And make it concentric. Sorry, English was failing me. To the hole. And we'll just save that for the moment. We won't bother putting ground supports in. We'll just build our motor first. There we go. Beautiful, isn't it? Now I haven't done one that didn't mirror this plate around to the other side because there only needs to be one motor mount on it. So the other side won't have a motor mount, so we won't mirror it. We need to draw it as a separate part. Plus I might do other things, I'm not sure. But these things I'm pretty sure they're going to be the same on both sides. The drive motor mounts, the weapon motor mount won't be the same on both sides. Anyway, you also need a motor in a sprocket, so just grab those out if you remember. It's actually a bit tight there. You almost need to make the weapon hub bigger. So maybe we'll make that weapon hub a bit longer, just so we can get a bit more in there. Oh, that's 60, make it 75. Yeah, that fits much nicer. Now you can constrain that bit up sprocket to the end of the pipe. Still haven't quite decided if I want that inside or out. If I put it inside, it's probably not enough room. Unless that comes out like that, and then that'll be too heavy. I'm better off putting it up here and making it outside the robot. So, we move it closer. That's pretty easy. All we have to do is change the number of links in the chain. It's not really. It's alright. The sprockets aren't going to hit each other. Probably about the closest we can actually get them together. And the closer it is, the less likely it is to derail. So, I think that's all good. Next time we have to put in some supports to keep the disc off the ground.